right, we'll get started shortly. We're going to let our numbers settle down for a bit. A few more people joining us. Go ahead and get settled in. I'm so glad you're here today. This is going to be such a great workshop. Just deciding if I should kick my dog out of my office yet, but I think he'll be okay. So my own personal Carol the dog will be hanging out with us. Welcome, everybody. Very excited to be with you today. And while we are getting settled in, we're going to have a chance to do some introductions in chat in just a moment. If you would like to start that, you certainly can. You can tell us where you're coming to us from. Have you taught game design before? Do you have experience with Unity? Is this new? Are you just here to explore? Anything you'd like to share. We'd love to see where people are joining us from. And we'll get started shortly. Just looking at names, and I definitely recognize quite a few of these names. I think I might be meeting some of you for the first time. Yep, I'm definitely recognizing some of these names. Great to see you. Wonderful to see you. All right. Thanks, Matt. If you'd like to share any of those things, that would be great. All right, I think our numbers are starting to settle down. So again, just let me say welcome. We'll go ahead and get started. For those of you who don't know me, my name is Lori, and I'm a PD specialist here at CodeHS. And I'm going to be kicking off our workshop for us before I pass it over to Matt. He is going to be the real star of our show. So we also have Matt, who's one of our fabulous curriculum developers with us today. And he is going to be taking us through this workshop. We have a few more people joining. We have not shared any links yet, so no worries. We'll make sure to keep sharing those as people keep joining today. Let's see. There we go. I'm just going to take a quick peek at who we have in chat. Welcome, Zach from Texas, Catherine, Arkansas. Very nice to see you here today. We've got New Mexico, New York, Tennessee. Just in Tennessee a couple months ago. Woo, Portugal, welcome. Welcome to Portugal. Tennessee, Oklahoma, Ohio. We are seeing people from all over the world. This is very exciting. Oh, cool. Very excited. Hello to Mexico. Welcome. Maine, California, Seattle. Seattle's one of my favorite towns ever. One of my favorite cities. You can tell I'm a small town girl. I just called Seattle a town. All right, everybody, go ahead and keep tossing those into chat. And I'll keep an eye on that and keep welcoming you. So we are very excited you're here with us today. Go ahead and let's go to the next slide, Matt. So one of our first links of this workshop is right here on this slide. Lindsay's going to go ahead and toss that into chat for us. If you would like to access the slides today during the workshop, and that might be helpful to do that, go ahead and click on that link, codehs.com/unity-slides, or go back one slide for me, Matt. There you go. And you can also scan that QR code if you have a mobile device that you would prefer to look at the slides on. I'll give you just a couple seconds on this slide. And I also neglected to mention our other CodeHS team members who are on this call today. We have Lindsay with us. Lindsay is a PD specialist also. She's waving at you. And we have Don with us, who is also a PD specialist here on CodeHS. And they will be helping us out on the back end. All right, let's go ahead and go to that next slide now, Matt. So because we have a pretty big group with us today, we want to make sure none of your questions get lost. We want to make sure we can get everything answered. And if we can't answer something during the workshop, we want to make sure that we're going to be able to come back to that. So if you could please go ahead and add any questions that you have into our question parking lot, that would be great. And that link, Lindsay just tossed that into chat as well. There we go. And that link for the question parking lot is codehs.com/unity-questions. There will also be some links for the workshop included on the question parking lot as well. Okay, and you've got that QR code if that's easier. All right, let's go ahead and go to the next slide. All right, so teachers, if you have never used CodeHS before, we invite you to please sign up for your free teacher account. Just browse to codehs.com/signup to create your free educator account. If you are just creating an account for the first time today, do know that we do go through a verification process for teachers. So if you're looking for things like solution references, you won't be able to see those probably today, but we will get you that access very soon. All right, if you have an account already, go ahead and sign in. Once you create an account, you can go ahead and sign in. And then let's head to that next slide. Once you are signed into CodeHS, please browse out to this URL, and Lindsay has just tossed that into chat for us as well. If you could browse out to codehs.com/go/45DFA, that will enroll you in today's workshop section. In order to see the content that Matt will be demonstrating during the workshop today, anything that's in the game design course, you will need to be enrolled in this workshop section. And if you are in a place, maybe you're traveling or you're just in a place where it's not going to be very easy for you to access this today, you can always enroll in this later. We are recording, and we'll send out the link to the recording as well as any of the resources used today in that follow-up email. So you can definitely do that after the fact as well. And we'll be watching this on the back end to make sure that everybody gets enrolled and that we don't have any trouble enrolling. And if you do have trouble either creating an account or enrolling in the course, please go ahead and drop a message into the question parking lot, and somebody from our team will make sure to help you with that. It looks like you're all pros. You're in. So your section is filling up fabulously, Matt. That's awesome. And if you're just joining us, we're going to go ahead and toss some of those links back in there for you in just a little bit. All right, let's go ahead and go to that next slide. All right, we got one more link. So if you're just joining us, I would wait to click this until you sign into CodeHS. But for those of you who've signed into CodeHS, you definitely want to click on the attendance link. So Lindsay has that in chat now, codehs.com/unity-attend. This link will let us know that it will officially mark you as checked into the workshop. And this link will also allow me to send you all a certificate of attendance for this workshop. So sometime after this workshop, it'll probably be later this evening, I'll go ahead and send those certificates out to anybody who's clicked this link, and you'll have a 2-hour certificate for attending the workshop. All right, so don't forget to click that link. That's a good one. They're all good ones. Who am I kidding? All right, let's go to the next slide. I think we're almost there. Okay, so our agenda for today, we have a ton to cover. So I'm going to go through this quickly so we can get over to Matt and have him go through all of his cool stuff for today. So we're getting through this virtual check-in process right now. We've gotten you enrolled in the workshop demo section, and we'll get, if you haven't enrolled yet, that's okay. We'll get those links tossed out into chat again for how to enroll. And then I'm going to pass it over to Matt soon, and he's going to take us through a quick course overview so you can see what exactly is in the CodeHS Game Design and Unity course. It's an amazing course. If you haven't checked it out, you're going to love it. Then he's going to take us through some sample game design lessons, and we'll talk a little bit about what you're seeing there. And then as we get through this first, hour and a half-ish of the workshop, we'll take a quick break. And we will go into, we'll have an option for a couple of additional breakout rooms. You'll actually have some time to connect with other teachers before that during the lessons. But for that last, 30-ish minutes or so, you'll have an option to choose from breakout rooms. You might want to go talk to Matt some more about the curriculum in the course. And that is a fabulous time to connect with Matt, get some questions answered, connect with other teachers who are also thinking about teaching this course, and really get some more insight into what's in the course. The first breakout room will also be customizing your course. So if you're curious about ways to actually be able to customize a CodeHS course, you can pop into that room and I'll talk about some of those strategies with you. And then we'll wrap up the entire workshop with a little bit of Q&A, few last links, and some other wrap-up things. So I think that finishes up my section. Let's go to the next slide. It does. So let me just say again, because I didn't give him a very good introduction at all. So Matt, we are so very happy to have you here. You are our game design, Unity, just everything expert. So we are thrilled you're going to be doing this for today. I'm going to turn it over to Matt.
Thank you so much, Lori. I'm so happy to be with everybody today. Good morning and good afternoon if it's just now heading into afternoon for you. We're going to take a look at game design in Unity, and we're going to take a deep dive into this course. Before I start looking into specific lessons and things like that with you, let's take a higher level overview of what this course entails. It's a one-year course. We had both semesters kind of broken out last school year, but we've actually put those both together now. So we do have it as a full one-year course. It's designed for high school, and it goes through everything pretty much that you need in order to build a basic game in Unity, and goes through all that game design goodness. So students will attain the knowledge and skills required by game industry experts. They learn important digital design skills using that Unity platform. Those are the two main focuses that we have for this course. Students learn about the different aspects of game design, the game industry overall. What does it mean to be a part of a game studio? It includes game history, legal implications, ethics in gaming, and all different kinds of career paths. Maybe they're not interested in programming or coding. Maybe they want to get into more artistic forms. We cover that as well. Students also delve into the specifics of using the Unity platform game engine itself to design their games. They'll be introduced to 3D modeling by working with different game objects, learn about the intricacies of storyboarding, planning out your game, and they'll also acquire the fundamental skills that are needed to design a basic game. Who's it for? This course is intended, like I said, for high school students with general technical skills and basic computer literacy. They won't need to have any programming experience coming into this course. We give them a lot of the C# scripts and programs that they need. We do give them a little taste of what it means to tweak some of that C# if they're interested in going above and beyond in those areas. But this is really a good baseline game design course, teaching about how do you design different levels for games and how do you actually build those 3D games within a Unity game engine, that type of thing. It serves as a great baseline. It'll keep the attention of your students who are either maybe both artistic, but also analytical in nature. This course, again, like I said, is intended for high school students with some general technical skills, but they don't need to have any type of programming background. There are some tech requirements that are special to this course. Both students and teachers will need to download and install the Unity platform in order to teach this course. This is actually built into the instruction hours and is part of the lesson plans for the course. So when you see the full course overview as it is, part of those course hours does include the installation of the software itself. So you won't need to worry about getting that done ahead of time unless you would prefer to do it that way, or your IT department requires you to do it that way. I do recommend that at some point you review the system requirements, and if we can get that link at some point added as well, it may be in the parking lot document too, but we'll have that link available elsewhere for you as well. This is Unity's documents. It leads you straight into their system requirements. It'll give you all the specifications and everything that you need for your hardware in order to run the Unity game engine. All right, and there are some different versions of Unity. When you install Unity, you get a Unity hub, which is sort of like the application that runs all things Unity. It's where you open your projects from. It's also where you install Unity from. And it's also where you would be able to look at different versions of Unity that could be installed on your computer. So you could have more than one version of Unity installed, but Unity Hub manages all of that. It keeps it all organized for you. So occasionally you'll hear me mention Unity Hub. That's what I'm referring to. And I'll show that to you here in a little while. Unity supports many long-term stable versions of its software. The CodeHS course will use this version of Unity. It's 2020.3.12 F1 LTS, and that LTS just means long-term support. And basically what we've done is we've chosen one version, since Unity updates its versions very frequently. We've chosen one so that all of our Unity projects that students can download, they're basically starter projects for the different tutorials and lessons. When they download those Unity projects, we've got an established version that we can say, these will all work with this version. You can use newer versions of Unity. There's a way to upgrade those, and I will try to show you a little bit about how you might go about doing that. It's all controlled within Unity Hub, but you cannot use older versions of Unity. So you can't go back to 2019 or 2018. You may have some more issues with the different projects that you download for the course if you do that. But this is our preferred version that we would like to have installed for Unity. And this kind of goes over what I had just said. And they have more documentation about that on the Unity website if you're interested in what specific versions are out there. There's some that are in beta and long-term support, different variations. So if you want to read up some more documentation, they have that available on the Unity website. So let's get into the course structure a little bit. Now, like I had mentioned, we did do a little bit of restructuring of the course, getting it prepped and ready and updated for next school year. So coming out for this fall here, we've got a nice refreshed look of the course. Basically, you're going to have a bunch of different modules. The first few will really get students into game design, learn a little bit about the history of the game industry, and also game studios in general, what types of careers are out there. That'll be in exploring the industry as well. Then we dive into what was called Unity Fundamentals. It's now getting started with Unity, and I'll show that to you here in a moment. But it basically is that one module that helps you get the software installed and set up. So you can do that as part of the course, or like I said, you can do that prior to teaching the course. We also have some different projects that students will be doing throughout, and those will be specific modules that students can work on an open-ended project of their choice. There are some requirements for each of the different projects, so they'll have to follow some guidelines, some specific game design requirements that we put in place. But for the most part, it gives them a flexibility and open-ended experience where they have the opportunity to build a game of their interest. And then also we dive into a little bit of ethics in game design. There are several other modules within the course as well, and we'll get into some of those other modules too, but this just kind of gives you a breakdown of all the different modules and how they're set up. Within each of these modules, then you can expand it, and we have various lessons that they'll dive deeper into that overarching category or that overarching topic. And again, here's those lessons broken down out of each of the different modules. So diving into one of the lessons, then you can look at how it's broken up into activities. Most of the lessons will begin with a video, something that shows them some of the overarching concepts that will be taught in that lesson. Then also we have included some quizzes just for a check of knowledge, check for understanding. And also we have a lot of free response activities in here as well. This course is a little bit different than some of the other CodeHS courses and lessons that you may have seen before and may have used from CodeHS. This one, we do a lot of the work in Unity itself. Students will actually build stuff in the Unity game engine, but then we bring them back into the CodeHS environment where they can reflect on that. What did you learn? What was difficult for you? What do you think you would have tried different next time if you were to create this type of activity or game or whatnot? So those free response questions are really important to get a handle on how your students are doing. How do they feel about the activities? Are they understanding the different tutorials that they've gone through? So we do include those throughout the course. Each one contains usually about 2 or 3 questions that students can write a pretty brief answer to. And then they can also then submit their Unity projects as well for your review. So like I said, we have several modules in this course. These are all of them. So the full year course starts off with that intro to game design, explore the industry. There's that new get started with Unity module where it helps them get the Unity software set up, ready to go. Then we dive into creating interactive game worlds. This is a little bit newer structured lesson that or module that we've included in here. And it basically helps students get a foundation of how do you build a three-dimensional model within the Unity environment, and how do you have these different game objects interact with one another. And I'll demonstrate one of those lessons here in a little bit. We also try to break it up a little bit so that not every unit or module is very Unity specific. So create interactive game worlds, very Unity specific. It dives into the Unity skills that they need to know in that game engine. Legal and ethical consideration, they don't spend a lot of time in Unity in that module. And then in the projects, they again are back in Unity. So we have some technical modules, and then we kind of vary it up with some other modules that give them a more in-depth look at the game design industry overall. So that's sort of how the course is broken up. All right, let's take a look at some sample lessons now. We're going to take a look at some lessons that are in the workshop section. So again, this is that link that Lori had shared earlier on, where you can enroll in the workshop section. And yes, this is a year-long curriculum. It's a year-long course. And you can take a look at all of the different modules and lessons and things that I'm going to be previewing for you today. We'll take a look at those. All of those will be in this workshop section that Lori sent out the link for earlier. So this is what that section looks like. I did include some modules that I'm not going to talk about too in depth, just for you to take a look at and preview. Those modules include the intro to game design. This is the one that dives into history of video games and a quick overview of game design. I did also include the get started with Unity module that I talked about, where it goes through the setup process. So you can take a look at that, see what that entails. It includes the link for all of the system requirements. So all of that's in there for you as well. The one that we're going to start diving into in a little bit here is the create interactive game worlds. And I'm only going to touch on one lesson in here, and that's the game physics lesson. So prior to diving into game physics, students will already understand a little bit about the Unity game engine user interface. They'll also understand a little bit about building with different prefabs and making their own three-dimensional shapes and things. So they have a little bit of knowledge going into the game physics lesson. So don't think that we throw them into game physics right away without, without giving them any other tools besides just going into game physics right off the bat. So before we dive into any of that and actually looking at the Unity pieces in that, I'm going to run the first video from that lesson, from the game physics lesson. And we'll take a look at this video. And then after that, then we'll open up Unity and I'll go through the whole download process of a starter project, what that looks like, and we'll take a deeper dive into that. So this is the lesson video for game physics. And it covers rigid bodies and colliders, which you're going to learn a little bit more about later on today. And we'll take a look. Hi there. In this lesson, you're going to practice adding rigid bodies and colliders to create puzzle and projectile games with a physics engine. So let's get started. Many game engines and game development libraries include a physics engine. A physics engine is a system that simulates aspects of a physical environment so that game objects can accelerate and decelerate correctly and be affected by collisions, gravity, and other forces. Rigid body components in Unity enable your game objects to act under the control of physics. Rigid bodies can receive forces and torque to make your objects move in a realistic way. Game objects must contain a rigid body component to be influenced by gravity, act under added forces via scripting, or interact with other objects through the physics engine. While the rigid body component applies physics to game objects like gravity, it doesn't stop a game object from falling through other objects. For that, your game objects need a type of collider, or a character controller, which has its own built-in capsule collider. Depending on the shape and purpose of your game object, you can choose from a variety of colliders. Box colliders are great for 2D game objects, cubes, and platforms. Sphere colliders are good for spheres and spherical-shaped characters. Capsule colliders are good for oblong game objects. Capsule colliders are also included in character controllers. More on that in a later lesson. Mesh colliders are great for highly detailed game objects that require precise interactions by the player. However, mesh colliders also require a great deal of hardware performance during gameplay and aren't recommended for most game objects. Wheel colliders are a special type of collider used to control the movements of wheels and gears, typically for wheels on a vehicle. Terrain colliders can be used for special terrain surfaces. On the left, you can see a sphere collider that's been added to a sphere rigid body game object. In the ball toss gameplay on the right, the sphere colliders on the balls collide with the box colliders on the pyramid of boxes. The rigid body component on all of these game objects tells Unity how much mass they have and whether or not they should fall to the ground with gravity. This creates a falling box effect when the box are hit by the balls. In this lesson, you'll be using a collision controller C# script that allows you to apply some collision actions to your game objects. If a game object collides with another, you can change the game object's color, destroy a game object tagged as an enemy or collectible, or you can even add an audio clip that plays upon the collision. This script is added to the player game object in your game scene. Now that you know a little more about how rigid bodies and colliders impact game objects, it's your turn to play around with some game physics in Unity. Okay, so like I mentioned, students are going to have some background before going into this lesson. So they'll know a little bit about building some of those 3D shapes, the spheres, the boxes, things like that. So this lesson here starts off with that video, and then we'll jump into some more rigid body and collider mechanics and things like that in Unity itself. Before we get too far into that, I'm going to get caught up here on some of my slides. Okay, and so couple of different things that you may have gotten from this video in talking about rigid bodies and colliders and things like that. I want students to first of all think about, in an opening discussion to the class, brainstorming different types of forces or interactions that occur in real life. And so a lot of what we do in this course is comparing the science maybe behind some of the things that you see in real life and how they may or may not look differently or behave differently in a game environment. And that's very true for this game physics lesson that we have. So answer this in the chat if you could. Okay, so a door closing, that's a really good interaction. You've got the touching of the door. If you push the door, how fast is it going to slam shut? That's a really good example. Thank you for that, Matthew. Walking is another great example. That's fantastic. You've got the actual coming down of the foot onto the ground. Later on in the course, we get into particle effects. If you're walking in dirt, are you stirring up some dust behind you? That's where we get into some of those special effects. Gravity, for sure. Gravity is a big one. And that's something that we really want students to understand. If you're building a game and it takes place on Mars, your gravity is going to look a little different than a game that might be taking place on Earth or another planet or whatnot. So you can actually adjust that in your game engine for, whatever situation you're going to have in your game environment. Projectiles, yeah, like we saw in the clip there, throwing balls at something, a toss game. They actually do create that as part of the tutorials in this course too. I don't know if we'll get time to dive into that one, but for sure. Auto collision, momentum, jumping and bouncing for sure. Teleporting, yes, absolutely. If you've ever watched cartoons where, some force may cause the character to squish a little bit, as they come down and hit the ground and then they come back up again. That's actually a force that's an additional force that's not in real life, but we're giving it some of that additional force. You can do that within Unity as well. So lots of different types of things. Friction, fantastic. That's great. Those are really good examples. And these are really good ways to tie science into what you're talking about in this game physics lesson. You can really get your science teachers involved in this as well and talking about, physics and how things interact and behave in the real world. Now let's take a look at what that looks like in the gaming world. Could be a lot different, right? So a physics engine simulates real-world physics. Choose yes if you agree and no if you disagree. I'm curious to see what everyone says here. Oh, we've got several no's, a few yeses. It can. All right, middle of the road. I don't have a third option there, but yeah. This is a very binary question here. Yes, okay, yes. Great. This is a really good time. Yeah, you decide the rules. This is a really good time to ask your students, what does the word simulate even mean? That could be an ongoing conversation among your students as well. What does that mean to simulate something? Does it mean that you're trying to make it exactly the same? Does it mean that it's the same but kind of different, or that it's not at all the same at all? There's a whole different wide variety of answers that you could come up with. What does simulate mean to you? Simulating is actually what the physics engine does. It is trying to simulate or give it that real world sense. You're trying to replicate something that is found in the real world. That's what you're trying to do. So in our terms for this course, simulate does mean that we are trying to replicate that real world physics. And that's what a physics engine does. And Unity, as a game engine software, has a physics engine built into it. And that's something that students will learn along the way too. All right, thank you so much for participating in those questions. That was great. So we did watch the video. We took a look at rigid bodies and colliders. Now we're going to go through a little bit more of this lesson. And before I dive too much into that, I want to give you a sense of what these technical lessons really look like. And for each of the different ones that are very technical in nature with Unity, we start them off with downloading usually a Unity project. And this is a starter project. It doesn't give them, all of the answers. It doesn't have the game finished. It's basically providing them with all of the assets that they might need. It's also giving them maybe a setup scene. So a game scene that's already kind of pre-ready for them to start the tutorial. So I would call it a starter Unity project. Then after that, we might have a connection in there. This one does. Not always do we include one, but this one does. It dives them. It's a video that dives deeper, a little bit more into rigid bodies. And then we have, you'll see later on, another connection video that gives a little bit more specific information about colliders. So we've kind of provided those as separate entities within this lesson. Then we have all of our tutorials for Unity as notes. And those notes can be accessed in the CodeHS course. And students can access those in a variety of different ways. I'll demonstrate some of those in a moment. And once they've completed those tutorials and gone through the notes, learned about the concepts, how do you do this in Unity, then we provide them with those free response questions that I sort of talked about earlier on. And that will kind of end up their tutorial. So each tutorial ends with that free response set of questions for them to reflect on what is it you just learned and are there things that you might be struggling with. So let me jump back over here to the course and we will take a look at some of those for game physics. All right, let's go into download our Unity project. Now, this Unity project that we're going to download is called physics-bailey.zip. And we've provided them step-by-step instructions on how to download the Unity project. Sometimes these are a little different. They're not a project, but they're actually an asset package. And I'll talk more about that a little bit later as well. But it's very similar instructions, very similar procedure, just a few slight changes. So we will click on the link here and find our Physics Bailey. You'll see that there are two different zip files in here. The Physics Bailey one is the newer one that's for the full year course. Those are the updated files. I have left the older files still in here, so you may find some older ones within the course, but make sure in the directions it does say, make sure to get the physics-bailey version. And if you want to get a better understanding of who Bailey is and why the course is named after somebody with the last name Bailey, you can check out the game industry history lesson, game history lesson in the first module. We'll give you some more insight on that. So I'm downloading, make sure to see if it's done there. It downloaded pretty quick. These updated files actually do download a lot faster than the older ones do. And what I'm going to do now is open up my Finder since I'm on a Mac. You may not be on a Mac, you may be on a Windows device. You just open up your Explorer window. And I'm going to go into Documents, and you will see Unity right here. I've got mine set up so that I need to make sure that my files are in this Unity folder. It does tell you to do that in the instructions. Unity is kind of weird about how it will open Unity project files. You cannot store these Unity project files on a shared network drive. So I advise you to have students work on these using a local drive of some sort. It just works better. You can sometimes get it to work on a shared network drive, but it does work better if it's hosted locally. That would be something just to keep in mind. I'm going to move my zip folder. Actually, let's unzip this here. So I'm going to unzip it here, and then I'll move the folder over. So once you unzip that zip folder, it'll give you your physics folder. And I'm going to move that into Documents, and I'm going to put it in that main Unity file, or that main Unity folder. And you'll see that Unity, typically when it's installed, it will automatically set up a Unity folder. Usually it will be under Documents or My Documents if you're on a Windows computer. So check those two folders. That's usually where Unity likes to put it. I'm not going to say it always does, but usually that's where you'll find it. And that's usually a really good folder to keep all of your projects in, all student projects in when they're working on these. So now that it's here, I should be good to go. I want to make sure it's in my Unity folder. Now we're ready to jump into Unity Hub. And I have Unity Hub already installed. And again, I want to stress this is not Unity. This is Unity Hub. They're two separate applications. Unity Hub is sort of like central command. It's the control place of all Unity, Unity projects, Unity installations, all of that. So if you need to install another version of Unity or the version that we recommend in this course, you can click on Installs, and then you can install the editor right there from the hub. So once you have Unity Hub installed, that's one way that you can install the version of Unity that you need. And you can see that I already have it installed here. And it walks you through step by step in the course how to do all of this. So I'm going to go to projects. I have no projects here. I'm going to open one, the one that I just downloaded. So let's click on Open. And it automatically went to my Unity folder. which is great. There's my physics folder, and you don't want to click on any folders inside that physics folder. You want to actually open the physics folder in Unity. So we click on physics and select our open. And because I selected open, it will open it automatically in that version of Unity once it's done adding it to Unity Hub. So that's what it's doing right now. All right, and here is our project. So this is the project that we need for game physics. And what I'm going to do right now is just sort of rearrange my windows a bit so that you can see what things look like in the browser and also what things look like in Unity. So we downloaded our Unity project. We've walked through all of those steps there. We'll ask students to change the name of it. So we'll have them call it usually like physics dash and their name or something like that. It walks them through those steps. And then when they're all set to go and they've got it ready to go and they've opened it, again, this one has connection videos. I'm going to skip those just for our time's sake, but I am going to jump into applying rigid bodies. We'll take a look at the tutorial here. So each tutorial is in CodeHS. It's a little different than how it was last year, but there are several advantages of us having it in CodeHS as a note like this. One advantage is that students could open this up on a phone or another device or another screen if they wanted to. They can also refer back to these tutorials very quickly and easily without having to open up another project in Unity. So it's very quick to refer back to. Also for students with disabilities, if you would like to print off the tutorials for them, just so that they have a hard copy of it and it's easier for them to navigate, you can do that a little bit easier from our platform than how we used to have them set up within Unity. So this makes it a lot easier to access those instructions for students and for teachers too. So I'm going to pull those up and we'll walk through some of this tutorial here together. I'm just going to adjust my screen just a little bit more there so you can see a little bit more of the environment. Now in Unity, we have several different areas here that students at this point should already understand the different aspects of the user interface. But we have our hierarchy over here. This is sort of like all of our game objects, everything that's in our game scene. This is our scene editor. Down here below, we have all of our project files and folders that we can choose from. And then over here, we have our inspector on the right-hand side. And that inspector is going to be where we do some of our more intricate work with properties and things like that. So rigid bodies. This gives you a little synopsis of what rigid bodies are, how they work, why they're important. Rigid body components let game objects respond in a realistic manner to different forces that are applied to them. These are different than collisions, and students will hopefully get a better understanding of the difference between collisions and rigid bodies within this lesson. We're going to explore rigid bodies just a bit here. And to do that, in our Unity project, we've got our scenes ready to go here. I believe I'm already in the scene that I need. Let's click on my scenes folder. And it says open the collider scene, which the collider scene I can see up here is already open. So we're good to go there. In the hierarchy window, we're going to create a new plain game object. There's a couple different ways that you can do this, but I'm going to right click on it. I'm going to go down to 3D object. This is one of the things that kind of irks me a little bit about Unity is that I don't consider a plane a 3D object, but but it is listed under 3D objects. So that's why I put a note in there that it's under the 3D category. So here's my two-dimensional plane from the 3D category. Also, I'm going to create a new sphere game object as well. So let's do that. And we're going to just leave this called plane. And I'm going to do a 3D object and we're going to do a sphere. So here's my sphere. I'm going to pull it up just a little bit. Just use a transform there and pull that up just a tad. Now, some of these shortcuts that I'm using with my mouse, I'm clicking the wheel in order to pan from left to right. I can also orbit by clicking on the right click of the mouse. All of these are provided in the help under Unity. So if you click on help, it'll give you keyboard shortcuts, mouse, maneuvering sort of clicks and things like that. It'll give you all of that information within Unity. All right, so we have those added, and I need to rename my sphere to ball. So let's rename that. Come on. There we go. To ball. All right. 4 materials with basic colors are provided under the materials folder in the project window. So let's go to the materials folder and check these out. Oh my gosh, we have 4 different materials down here: blue, brown, purple, and turquoise. We're going to do something with those materials and textures. Students will get into those a little bit more in depth later on, but these are basically allowing us to add sort of a shine to it if it's made out of plastic or metal. It'll also give it a color. So that's the main purpose in this activity, what we're trying to do here. So we're going to apply one material to your plane and the other to your ball. It's completely up to the students. As long as they're 2 different colors, that's really all that matters in this activity. We want students to be able to see the difference between the ball and the plane and what's actually happening in their scene editor. Okay. Now we're going to do some adjustment to the game object properties. So that's where we look at our inspector over here. On this side, we can transform things, rotate game objects. We're going to select our plane game object. So I'll select that here. And under the transform component, which is located right here, our position is going to be X, Y, and 0. I want to set all of those to 0. So X, Y, and 0, I'm going to set all of those to 0. Rotation, I'm going to set to X is 0, Y is 0, but I'm going to change my Z axis. I'm going to change that to 5, and that's going to give me a tilt. So it's tilting my plane just a little bit there. And that's important because we want students to see how physics are applied to the ball when it hits that tilted plane. And you can get into more specifics with your students about the X, Y, and Z. We talk about that in some of the earlier lessons. Also note the rotation parameters will tilt your plane slightly, so we give them a little bit about what they should expect to see if they do it correctly along the way. Select your ball game object and set the following parameters for it as well. So we're going to change this transform position also to 0, but I want it to be raised above my plane. So I'm going to give it a y-axis of 2. And I'm going to change my Z to 0 as well so that it's centered over my plane, but it's raised up a little bit. And let's see here. My rotation should be 0 all across the board, and my scale should be 1 all across the board. So scale of 1 basically means that it's it's a 1. A 0.5 is going to be half of that scale. You can double it, those types of things. So that's where they can also change those and manipulate the shape of it as well. So if you extend the scale one direction but not the other, you may get more of an oval-like ball rather than a sphere type. So now we're going to select the play button and enter play mode and see what happens. All right. So when we select the play mode button, we ask students, what did you expect to happen? What actually happened? Well, I was expecting that the ball was going to fall and hit the plane. What actually happened? It didn't do anything. So now that we've done that, now let's try adding a rigid body and see if anything changes. Let's try that out. So we have our plane, we have our ball, nothing really happened to it. So let's add some gravitational force to that. And I'm sure something will probably happen now. Select your ball game object again in the hierarchy window. And then in the inspector window, we're going to go down here to add component. And there's all different kinds of components that you can add down here. We want to take a look at the physics components. That's where we're going to head to. And under physics components, you get a wide variety of physics that you can add in here. Here's a hinge joint, by the way, for somebody who mentioned door earlier. That might be really important to have. Also, here's our rigid body. And rigid body is probably the one that you'll use most often in that physics component category. So we've added our rigid body to it. Now that we've got that in place, we're going to set gravity to true if it's not already, which it is. Use gravity. That's set to true by checking it. 1, 0, 0 point, or 0.05. Those all look pretty good. So let's try it again and see what happens this time around. Okay, so it did fall, and it is rolling, and it is still falling. So once it rolls off the plane, it continues to fall. So now students can see the impact of that rigid body. It basically allows for physics to be applied to any game object that's available. Let's see here. It does say that, let's see, remove the check mark prior to the title sphere collider in the inspector window. I'm not, oh, here we go. Yeah, the sphere collider piece is already applied. So if we remove that sphere collider, let's see what happens this time and see if it's a little different. And there you can see it's a little bit different. So now students can start to see, oh, what did rigid body do? It applied that gravitational force, and it also applied other forces to impact that object and cause it to have a force against it. And then what did the collider do? When the collider was turned off, it fell right through the plane. When it was turned on, you had a sphere collider that was impacted by hitting that plane and then rolling down it. So very cool stuff. You test the rigid body behavior, which we already did. We also asked students to play around with the mass a little bit, with the drag. What do those different things do? And we asked students to make up their own basically explanations of what those different things mean and how they interact in this environment after they've explored it a little bit. So that's the first tutorial, and basically understanding and exploring rigid bodies and what does that mean to apply a rigid body. So now students then can go in here and in the next activity answer a few questions about what they learned, what did they understand, what surprised them, what didn't surprise them, about this this game object, this ball, and applying rigid bodies to it. What were some things that changed? And then they can submit that here through CodeHS. Now we're also going to take a look at colliders. I'm going to skip over the connection video again, but this time let's take a look at colliders, and we're going to do a little bit more with colliders to explore it just a little bit further. What can we do with colliders, basically? So if it's not already open in Unity, open the collider scene, asset scenes. We've already got it ready to go. We're all set. Now we're going to select our plane in the game object hierarchy. In the inspector window, make sure a mesh collider component is present and checked. Mesh collider component is right here, and it is checked. Like we did with the sphere collider, if I uncheck it, it turns it off. If I check it again, it turns it back on. So you have that ability to toggle that if you'd like. Expand the mesh collider component. Let's take a look at all of its properties. We're going to use the default properties for it for now. These basically dictate what the material is for that mesh collider, how it acts as a collider on that game object itself. When it's triggered, is it triggering something else? Those things can also be manipulated using scripts, which we'll do a little later. So now we'll select that ball collider again, or that ball object again. In the inspector window, we'll locate, check mark that sphere collider again, make sure our rigid body is all set and ready to roll, pun intended. And we've already seen what that does when we select that. Most geometric colliders allow you to manually change the collider's dimensions. So you can change, if you wanted the ball to actually collide with that plane earlier than when the actual ball itself hit the plane, you can expand the collider and make the collider bigger than the ball so that it would collide sooner before the ball actually hits it. And it goes through a little bit of a demonstration of how that's done. It also talks a little bit about the gizmos, and the gizmos are really cool. If you ever get a chance to take a look at what the gizmos do, you can see it when I come in here just a little bit more. And the sun one is kind of in my way, but let me move that out of the way here. So what the gizmos then let you do is you can kind of see these light green lines that go around. Those are the rigid body, or I'm sorry, the sphere collider. Those are the gizmo basically that shows you where that collider's at. So if I wanted to manipulate that collider, I can make it larger, I can make it smaller. I'm not changing the size or the dimensions of the ball or the game object, just that collider. When does it impact and where is it going to impact? So if I edit this and change it, I'll just show you what this does. Once I have that sphere collider in place, it'll look a little weird. Because as it rolls, my collider is upward, and so it almost rolls like an egg in a way, because I've got that collider positioned and stretched out a little differently. But that's what you can do with the editing the collider over here, and we'll go through showing students how to do all of that as well. And basically, I just changed the radius of it. Yeah, set that back to 1. Nope. 0.5. Yeah, let's go with that. Okay, so now we've got it back to where we had it. And let's see here. Instead of manually changing the size, that just kind of goes through what I just showed you of, pulling that collider and making it bigger and seeing what it does. You can also go in and change the drag, the angular drag. What does that mean? What does that do? Offsetting the collider. It goes through a lot of that for the student and basically asking them to try different things. What does it do when you try this? How does it behave when you try this? And then we also, again, go back into asking students some questions about what they experienced. What happened when you pressed the play mode and you activated it? What happened when you tried two different, tried to expand the collider or add drag to it? So students get then that reflection of what did happen, and they can kind of make the connection of what these different components and properties do for the colliders. All right, the last one that I'm going to dive into here is exploring colliders a little bit further. We're going to, let me see if this is the one. Actually, let me go into collision events. We'll get into that. So I'm going to skip ahead just a little bit here because I want you to see some collision and how we utilize some of the scripts that are also pre-built into the starter projects. So we're going to add a physics material. If not already, make sure it's open and everything. Select the materials folder. And this is where we're going to create and store a physics material. So in addition to having these types of materials, we're going to create a physics material. And that is under, I think, material, right-click material, select physics material. Oh, here it is, physics material. There we go. Okay, and I'm going to rename this to bounce. So we know exactly what it does. Select your bounce material, and it gives us some information over here. This is where we can add some friction. Unity comes pre-installed with some awesome physics materials, and you can try out different ones. This is a really cool one that will allow us to bounce our ball. So we have our physics material property for bounce. We're going to keep the bounciness. We're going to set that to 1. We're going to keep that at 1. Bounciness. That's a fun word for the day. We're going to apply the bounce now to that sphere collider. So we're going to select the game, the ball in the hierarchy. And once we select the ball game object in our inspector, we're going to locate the material property. Let's see here. Material property. Looking for it. Ah, here we go. Way down here. So we've got our material property. And we're going to select the circle with the dot in it on, let's see, to the right of none physics material. Oh, let's see here. Some of these icons are a little tiny to find in here. Let's see here. To the right of none physics material. All right. Well, I'm looking for it here. Go to edit.
I think I'm going to invest in more glasses.
What was that?
I'm going to need glasses for myself, stronger ones.
Yeah, the font is a little
It is
small over on
tiny,
the
yeah.
side there. I'm looking for the non-physical material, and I'm not seeing it unless. Property. Oh, sphere collider component. Okay. Sphere collider component. Here we go. I'm looking in the wrong place. Sorry about that. All right, so here we go. Here's our bounce. And we're going to set that as the material for our sphere collider. All right, now that we've applied it, let's go to test and see what happens. Goodness, it helps if I look under the right component. There we go. And you get a nice little bounce effect. That's kind of cool. So we can also play around with the bounciness. So if you want to play around with that, you can see what happens when you crank it up to like 5 or 6, and see what kind of bouncing happens. Now, the last thing I want to show you is the collision controller C# script. We're going to add that real quick, just so that I can show you some other ways that students will manipulate their collisions. Under the scripts folder, students will find a variety of scripts that will be used in different types of projects. Some projects will have more scripts than others. There's always going to be a README file, and the README file, if students open that, it'll give them information in it, and they don't need a special editor for that. They can read it over here on the side, or they can open it up in an editor, and it's all in Markdown and formatted nicely. Unity doesn't do that though. But it does give you some more information about what each of these different scripts do. So if students want to dive deeper into that, they sure can. So that ability is there. What we're going to do is select our ball game object. We got to make sure we're on the correct object that we want to add our script to. And then what we'll do is in the inspector window, add a new script component, which is down here at the bottom. And it has all of them listed here. And I believe it's, collision controller script. So now that I've added that to this ball, we can do some really interesting things with this. I can change the color by selecting this and check marking it. And I might want to change the color to, let's see, we'll do blue. Make sure it's over there. There we go. Let me close that out. Okay. You can also destroy enemy, destroy collectibles. It's got a push power on it. So how much push or force can you push on a box if you want? And also audio, which they get into later on in the course. They'll be able to add audio clips to this as well, make a bounce noise or something. So let's play this and see what happens. And once it hits that plane, it changes the color to blue. And that's basically just changing the material of the object. We can also destroy our enemy. And in order to do that, I need to make the plane an enemy. So I'm going to change the tag to an enemy. And let's see what happens when we do that. You should see a couple of things happen here, hopefully. Boop. It bounced, changed to blue, and our plane disappeared because it was a bad guy. So those are some different collision things that we can, that students can explore through the tutorial. And it gets into tags, like I talked about with the enemy. It gets into that, talks about tagging different objects and how you can use that collision script in different types of projects. So these scripts were designed so that in a way that students would be able to use them for a variety of different games that they would want to build in their project. So they're working with scripts that they can manipulate and know how to manipulate when they get to those project lessons. All right, so that was a lot in Unity. Let me jump out of that for a little bit. Go back to this. Okay, and we've gone through a good chunk of this already here. I talked about tutorial reflections, what those look like. Hopefully that gave you an idea of what the lesson overall is like. Now we have a class closing discussion. What is the difference between rigid bodies and colliders? So given the tutorials and what we kind of explored together, what your students would do maybe individually or in pairs, What in the chat, if you could answer for me, would be the difference between rigid bodies and colliders in Unity? Feel free to just put an answer in the chat, whatever you think the difference is between those two. And you might say, thinking about what we saw, Barbara says colliders interact with each other. Fantastic. Yeah, they actually impact each other. They're hitting each other. Colliders detect rigid bodies. Rigid bodies are basically applying the physics forces to that game object. But if you want it to hit something or run into something like a wall, or the boxes that we were shooting balls at in the one video, you actually have to have a collider applied to that as well. The rigid body is not going to cut it for that. Yeah, rigid bodies applies that physics, all the physics components, that physics engine to the game objects themselves. Yeah. Colliders detect when two game objects are touching. Yes, and it could be two or more even. It could be a couple of different game objects hitting another object at once. If the ball were to hit like the corner of a four-walled room, it could hit both of those walls at the same time, or hit one slightly before the other and bounce off of both of them. Yeah. Rigid bodies are the standalone shapes, and colliders are how multiple rigid bodies would interact with one another. Yeah, okay. Rigid bodies are those, they're applying that physics to those standalone game objects or shapes, three-dimensional shapes that you have. And then the colliders are making them interact with other game objects in the environment. So yeah, absolutely. These are great. How could you adjust game physics that may not seem realistic to make them more believable? Go ahead and answer that in the chat. And this one is a little deeper thinking thought as well. So as we go through some of our discussion questions and even the free response questions, we try to get a little deeper level thinking in some of these. So getting them to think outside the box. How would you adjust the game physics maybe to make the, if they don't seem too realistic and you test it out? We always talk about test it out, make some adjustments. What adjustments might you make? Applying gravity, absolutely. We've got that rigid body on there. Is it doing anything? Did you apply gravity to it? Yeah. And that is a common mistake students will do too. They'll apply that rigid body, but forget to check mark that gravity box. Slow things down. Yeah, absolutely. That friction comes into play with slowing things down. If you come to a slide, are you slowing down as you are sliding? Absolutely. Rigid bodies simulate physics and collider. Okay, I think I've read that one earlier. Adjusting the rigid body values. Absolutely. Those values are really important. In a game engine, instead of always working in scripts or program code, you can also manipulate a lot of the values and parameters using the inspector that's on the right-hand side. And so we try to get students to understand that they're able to do a lot of that manipulation right there in the engine itself and let the engine do some of the code work on the back end for you. Fantastic. Some lesson alterations. I already talked about maybe printing off tutorials for students with disabilities, perhaps. You can also add slides to your own presentation if you'd like. These are a few others that other suggestions and ideas for videos, exercises, maybe doing them in pairs or small groups, watching the videos together like we did for the first one, but maybe the connection ones they watch on their own. You could do it that way. A lot of different ways that you can open and close your lessons as well. I chose doing a couple of discussion questions. We have some of those provided in the lesson plans as well. So, all right, and grading. A lot of questions come to me about grading. Grading projects is great if you can do it in person or have students submit their project files to you. They can store those onto a shared network drive if you wanted to do it that way, and then you download and take a look through them on a local drive. You can do it that way. There's a couple of other options of how you can share projects, Unity projects, that are outlined in the course, and that's in that Get Started with Unity module that I shared in the section for this workshop. So feel free to check that out. And then also grading the free response questions within the CodeHS platform itself. So a lot of different ways to approach grading with these. All right. Let's do a quick debrief breakout groups. How am I doing on time, Lori?
We are at 10 after the hour.
Okay.
So we definitely have time to do this. I think it's
okay.
a good idea.
Yeah, let's do that. Lori will we'll get some breakout groups set up here, and in your breakout group, you will have if you go to this link here, and I believe it's posted in the chat there as well, it'll take you to a Google Drive folder. And each of these, just find your group number and you can go in there and able to answer the discussion questions that are there. You'll need to use this printed out PDF lesson plan for the game physics lesson that I just went through. Use that to answer your discussion questions that are in there. And we'll give you a few minutes to work in a small group on those questions.
Matt, there were a couple of questions I didn't want to fall back into the ether that were asked, and I wanted to wait for a natural time to ask you. The first one, there was a couple of questions around Unity making new versions, each time, and what CodeHS's policy is going to be with regards to how long we support the version you mentioned, and what our updates would be like in the future. And then the other question was about getting a certification as a certified user after taking the year-long Unity course, what the feasibility of that would be.
Yeah, absolutely. I'll talk about the certification one first. We are trying to align those with Unity's certification exams. We're not 100% aligned with several of them, but we are very close in, I believe it's the Unity user artist exam that they offer, that certification, and then also the Unity VR, actually the Unity VR certification. We're very close to full alignment with both of those. We hope that in the future we'll be able to align with some other Unity certifications as well. They have a plethora of them, but we are working on those. We also have those, I believe they are all in our frameworks as well. I know they're in our frameworks, but I'm trying to think if they're on our marketing page for that as well. So I'll take a look into that, but we are aligned very heavily on those two, I know for sure. So students they would probably do fairly well on those two exams if they're interested in pursuing that. As far as Unity versions are concerned, we will probably update them later on down the road. We'll update our project, our starter projects. They will be a little easier for us to update in the future because of some of the updates we just made. But also for newer versions of Unity, these Unity project starter files, you can open them. You can, it'll give you the option of upgrading to basically upgrading your project file to the version that you have installed. So let's say you install the newest version of Unity. When you go to open that project file, it'll give you like a message saying in Unity Hub, it'll say, you don't have this version that the project was made in. Would you like to upgrade the project? You can do that, and it will try to open it then in the new version of Unity. Going backwards, it's harder to do. You can't do it with the older versions, but newer versions of Unity, you should have pretty good success doing that if you would be interested in doing that.
So similar to Photoshop, Illustrator, stuff like that, newer versions are always backwards compatible with projects they'd make now.
Yeah, absolutely.
Awesome.
Okay, so I would recommend go ahead and grab that link for the folder. There we go. I just copied and pasted that quick again into chat. But go ahead and grab that. Make sure you have that. I'm going to go ahead and open up the breakout rooms, unless we have other questions. I might have jumped in on that. All right. We'll go ahead and open up the rooms. Have fun, everybody. You should get that pop-up asking you to join. If you don't see the pop-up, click on breakout rooms at the bottom of your Zoom window.
creating a game.
This meeting is being recorded.
Okay, welcome back. Is everybody back? I'll be waiting on a few more.
Everybody's back, Matt.
Okay, great. All right. So hopefully you had a chance to take a look at the lesson plan for the game physics lesson, and were able to reflect on that, what you liked about the lesson that you saw, how might you implement this in your class. Also, I wanted to address a few questions before we moved on to the next quick sample that I'm going to show you. Some questions around different versions of Unity still, also regarding upgrades. Unity will not automatically upgrade the Unity version for you. That's something that you'll have to do in the Unity Hub itself. Unity Hub sometimes will get updated, and that might be something that it does, but it will typically prompt you if it's something you want it to do. So don't be afraid of, like, coming into class and, oh no, we've got this big update it's going to take the rest of the class to do. I totally understand where you're coming from. But yeah, it may prompt you, occasionally in Unity Hub. But it will not install other versions of Unity itself without you doing it yourself. So you'll have to make sure that those are at the version that you want to have installed on the program or on the computer. And they do that mainly for game studios, because game studios, the entire team has to be working on the same version. And so as they're developing a game at a game studio, they'll make sure that everyone has that one version installed that they can utilize for the projects that they're working on. And they don't want to be bothered with, upgrade to the new version or a new version if that's not what they can use for that current project that they're working on. So hopefully you shouldn't run into too many issues with that. As for Chromebooks, I've had several questions about using Unity on Chromebooks. If you have a really high-end, powerful Chromebook, you might be able to get it installed using the Linux version of Unity. But I have a pretty powerful Chromebook myself, and Unity struggles with it. So Unity is a very, very big program. It takes a lot of resources and hardware to run it. So Windows and Macs are definitely the route you want to go. You want to make sure you have a strong enough hardware in order to run that game engine. So Chromebooks are going to be very difficult if you do try to go that route to get Unity installed. But Windows and Macs, you shouldn't have any major issues with that. With that said, you might have where you could view some of the videos and maybe do, have them do some of the project stuff or the skills stuff in a computer lab or something like that. There might be some different ways that you could get creative with your IT professionals at your school district and how to manage that or implement that. So with that said, let's take a look at another sample lesson. I'm not going to go into as much as I did with the first lesson where I went through everything in Unity. I just kind of want to give you a preview of what some of the other lessons look like. In this lesson, what makes a good game? This is part of when students are getting ready to build their first game project. And like I said, some of the lessons and units or modules are very Unity technical, and then other ones are not. And this is one of those lessons that's not. It talks about different types of elements of a good game, what makes a good game, and it's very much a non-Unity specific lesson. So you could get into this and use, another engine or, whatever you prefer to use as a teacher in your classroom. If you wanted to utilize some of these modules, that might be a good way to implement some of the items from this course. It goes through elements of a game, fundamentals of game design. It has a video that students will watch and get some idea of what game elements are. Are you providing your players with a challenge, a goal for them to overcome or achieve? We get into a little bit about game mechanics. What are the rules that make up a game? What are some of the boundaries of a game environment that make it challenging? So there's a lot of aspects to game elements that we go through and talk about in this lesson. And then students reflect on that and think about the games that they want to build and that they want to create. And what are ways that they can make sure it's a fun game? Is it a game that people are going to want to play? Is it too easy? Is it too difficult? What could they do to make it less easy or less difficult? Do you need to offer like some sort of a tutorial to play the game? So a lot of different questions that we pose students in some of the free response items in this lesson that really are central to the games that they're designing for their project. So we want them to be thinking about that. And then in the very end of it, we talk about just an overall wrap up of fundamentals of game design. And before they really get into developing their project for this module, we want to make sure that students understand what are the foundations that that all game designers need to follow. They need to make sure that they have these different elements included in what they're creating and their process for building that game. So we go through some of those as well. I wanted to just give you an example of what a lesson looks like that's not Unity specific as well. I'm also going to go quickly through a third lesson. This one's called Make It Your Own. And later on in the course, we try to get students to we don't give them as much of guidance as we maybe did in the earlier one with the game physics and that. We try to get them to make it their own by applying some things that they did in the tutorials from that module. So this is the Make It Your Own lesson from, I believe it's the lighting effects in the special effects module. So at the end of the lighting effects module of that lesson, at the end of that, they go through making a scene, a game scene of their own using an asset package that we let them download. And that asset package gives them different kinds of game objects that they can work with: lampposts, cars, sidewalks, buildings, all different kinds of things where they can create a scene, and they can even create their own custom 3D game objects if they'd like, and then apply those lighting effects to that scene. So they're building something from the ground up, really, using all of the different tools and things they learned earlier on in that module. So that's a unique lesson structure that's a little more open-ended. Instead of giving them a starter project file, we give them a Unity asset package. And we teach them in the course how to use asset packages. And it gives them scripts that they can use, which are programs that they can attach, kind of like we did with the collision for the ball. It gives them a lot of different tools and materials that they can utilize to create that game environment. And then there's a reflection at the end. How did they create their environment? And what types of elements did they use? So that's another lesson example of something that's a little different. It is still Unity kind of specific, but we've given them a little more freedom to build something of their own using a lot of the things that they had learned prior to that. And we give them some guidance and requirements of what needs to be included as well. These are some other examples of how you could alter that lesson a bit, different ways of teaching the notes to them, going through discussion questions, or completing projects in pairs or groups. We've tried to make them open-ended enough that you could do that if you wanted to pair students up, have them work on a project together, or doing a make it your own project piece together. They can do that as well. So we're not going to run through that one. We're going to take a quick break, and then we'll do another breakout type session when we come back from our break. Lori, do you have anything before we jump to a break?
I don't think so. What you can all be thinking about is, would you like to chat with Matt about some more game design and Unity topics, or learn more about the course? That will be one of our breakout rooms. The other one will be for customizing courses, and you'll be able to choose your room when we come back. Let's maybe do just a super short break, about 3 minutes. And that way we'll have plenty of time for, we'll have time to get into any questions. So let's come back at about 36, 37 after the hour. Somewhere right around there.
All right.
Matt, I wanted to mention a really good question that came in from Zachary. He was asking about features, are actions. And once you commit to a set of actions, like when you're in CAD and the actions stack on top of each other and they're dependent on what happened before, how easy is it in Unity, similar to CAD, to go backwards in the timeline of what you've done to pivot and change to a different set of actions? Does it wipe out the actions afterwards if you go back? You know what I mean? Earlier in the flow, the stack of what you've done.
So it's been
a really good question. It's like a depth of knowledge. Like, okay, you've used SolidWorks and done things. Like that's a really good question.
Yeah. I would say it's been a few years since I worked in a CAD application, but if I'm not mistaken, some of them you can, like an inventor, you can do like a timeline and basically play it back or go forwards and backwards of the actions that you put things in a specific hierarchy within the application, if I'm not mistaken. You can't do it that way specifically in Unity, but that hierarchy on the left-hand side of the user interface, that's basically your it's sort of your, well, it's a hierarchy, but I mean, you have your parent objects, and then you can have children underneath that. So different child objects underneath that, and they're very dependent on each other. Game
things
object
that happen earlier in the design process, like earlier in the hierarchy, things after that depend on that, right? So that if you go back earlier in the hierarchy and you change something, it's going to have an effect on everything that comes later.
Yeah.
Got it.
Yeah, and a lot of it has to do with positioning, where things are specifically located on the X, Y, and Z axis, and also rotation. It's going to append or basically use those parent object parameters first, and then if the children parameters, if they change some, then it's going to offset it from those parent ones. So yeah, it is dependent on each other. You can't really do like a rewind and a forward kind of thing to see what you did and what you didn't do. So you would really just be like either moving things from parent to child or whatnot, or pulling things out and moving it to another place in the hierarchy. It's not really, you can't really see the progression, I guess, over time.
So Zachary, hopefully that helped answer that. What I would suggest you do is dive in and try to break something, like make a project, have some actions in there, and then try to go back earlier in the flow. That's what I would try to do, and try to insert something and see what it does to the children objects after you, let's say you have changed the parent object or something like that.
And we get into that later on in the course. We have a lesson where students create their own vehicle. Vehicles, in my personal opinion, are very difficult to do, just in any platform. There's a lot of hierarchy knowledge that you need in order to create a vehicle that has, because you've got each of your different wheels, and then you have wheel colliders that are dependent on those wheels as the parent object. And then you have, on top of that, you may have a hubcap or something like that. That's another mesh. So you have that game object, and then you have other mesh colliders. So there's a lot of dependencies that are in that lesson.
Like if you took the wheels out, you wouldn't just want the hubcaps floating there.
Right, exactly, yeah.
They would also probably disappear.
The opposite direction before, they're not rolling the right way, and it's all because of how the rotation was of a higher up object. So that one is very easy for students and teachers, I think, to kind of mess up a little bit on, just unintentionally even. And we've provided a few tools and tips to help students with that. But we do go through what's a parent game object and a child game object in that lesson specifically, if you want to dive deeper into that.
Cool. Agreed, Emily, with the timeline info documented in coding. I love comments, by the way. Comments are so important. Comments are underutilized by students.
Oh yeah, great suggestion. I like that.
All right, everybody, let's go ahead and get ready for the last little piece of our workshop today. And this has gone too fast. You all have been an awesome group to be working with. You've been so engaged and we so appreciate your questions. So we're going to go ahead and keep charging ahead and give you the opportunity to choose the breakout room you would like to attend. I know many of you have still got questions about Unity and game design. So if you want to head into Matt's room, that is going to be breakout room number 2. I've actually called it curriculum chat. So you'll see that as soon as I open up the rooms. If you'd like to learn a little bit more about the platform, you can definitely head into my room. And I'm going to go ahead and open up these rooms for you. Maybe I'm a little bit laggy. Give me 1 second. There we go. So now you have the ability to choose your room. If you need help choosing a room, go ahead. Let's see. Just drop a message into chat. Matt, you can go ahead and head over to your room. Lindsay, I'll be in number 1 in just a second. I think Don's heading out with Matt too.
Trying.
And I'll be, oh yeah, it moves around a lot and it's super hard to join, I think. So let me know if you need help. And for those of you heading to customizing courses, I'll be there shortly. I'm going to hang out here for just a second.
How do I get to the choosing a breakout room?
Do you see the breakout room option on the bottom of your screen? Let's see who's talking. Is that Kristen?
Yeah, that's me. Okay, I see. Sorry.
Okay, cool.
We
No,
always
no
use,
worries.
Microsoft Teams, so I'm not
Yeah.
used to.
It's so different. And I think it's kind of tricky in Zoom sometimes to find the breakout rooms. They like to hide. Does
Okay,
anybody...
thank
Yeah, you bet. Does anybody else need help? You know, in hindsight, what I could have done was stayed in the main room for the demo, and that would have alleviated this. Now I'm thinking, we've done 8 workshops, finally got it. I'm going to go ahead and pause recording because it's not going to record the breakouts. So stuff. There we go. We'll catch this last little bit. So that was way too fast. All of it. I just want more game design. I could listen to Matt forever. This was so cool. So thank you so much. And I know we've got more questions about this, so don't hesitate to let us know if you've got questions. We are more than happy to help anytime. And for any of those questions on the question parking lot, we will definitely take a look at those and make sure that we are getting everybody covered and your answers covered. And Don was the one who was primarily watching that question parking lot. So thank you, Don. That was awesome. We appreciate that. So few more resources for you today. Definitely take a look at some of the other CodeHS things. We've got some CodeHS micro credentials for teachers. So if that's something you'd be interested in, definitely check that out. Check out our course catalog for all the courses we have available. If you are not in the CodeHS Facebook educators group, definitely take a look at that. It's a super active group, really great community. We'd love to have you join. And also, if you're not a CodeHS certified educator, we would love for you to become one. So definitely check out that program as well. And we've got more workshops coming up, everybody. A lot of workshops. So this is our last, is it Thursday? It is. So this is our last workshop for this week. I don't know what day it is anymore. It's very sad. This is our last workshop for this week, but next Tuesday on June 28th, we will have teacher trainer Sean Razor, who will be talking to us about the CodeHS platform in a little bit more depth. So if you're curious about more about how to customize, how to use the sandbox, just different things about the platform, I definitely invite you to Sean's session. He's going to be excited to talk to you all about the platform. Then on Wednesday, we have Teaching APCSA with teacher trainer Joe Thompson. And so that will be on Wednesday. And we have another workshop on Thursday next week. And I think it's a Python workshop and should be great. I think that's the one with Kent Pendleton. I'll have to look at that schedule. So anyway, head out to codehs.com/3PD because there's too many for me to remember. Register for any, register for all, I'm good with that. We were all good with that. We want to see our fabulous CodeHS teachers at all of our workshops. Even if you can't come, we'll send out those, the recording after the fact. And one more link. Lindsay has been on top of those links. I've been just, keeping her busy. So if you could take a moment to give us a little bit of feedback on Matt's workshop today, that would be phenomenal. We would love to know how we did. If there's anything else we could do differently, and if there's anything else you'd like to see, don't hesitate to drop that on that survey too. We want to know what you need. We're here for you. So please let us know. But yeah, thank you for filling out that survey in advance. We appreciate it. And I just
Lori may be frozen right now. She had a bit of an internet connectivity issue earlier. I also want to echo what Lori said. It was such great conversations, but really good questions asked too, as well. And I learned a lot from this. So thanks for being a great community today.
Yeah. Thank you, everyone.
Bye, everybody. I don't think you can hear me. Can you hear me?
Now we can hear you.
Woo! See, Zoom's sick of my face. So thank you to the CodeHS team. Thank you, Matt. And thank you, CodeHS educators. You all are awesome. We look forward to seeing you at the next workshop. See y'all soon.